Okay, so when you're finding the sum or difference of functions, a sum of functions could be, okay, h of x is equal to, and you could say f plus g of x, or you can write it as h of x is equal to f of x plus g of x. These x's are all the same. Whatever the x value was at the beginning, it maintains itself all the way through. The x value is never added. It's just the same x value all the way through. In this particular case, you're thinking I'm adding the y's when my x was this, but the x value is always the same. The same follows for subtraction. So you might see something that looks like this. Another way of writing that would be h of x is equal to f of x minus g of x, and again, the x value is always the same. So whatever that ordered pair was at the initial x value, it's going to be the same x value all the way through. And then for lesson 10.2, it was product and quotient. Now, when you're doing the quotient, just remember you can't divide by 0. So any x-intercept that lands in the denominator, we can't divide by that 0. So that becomes a vertical asymptote, okay? You can never divide by 0. So just remember with quotient, there's always like non-permissible values that might be associated with this, and they would come from any x-intercepts in denominator. So if you see a graph where if there's an x-intercept from your quotient, it's going to happen in the, you're going to be trying to divide by 0 and you can't do that, right? So maybe that's not the most important detail here. But what I need you guys to know is that if I'm finding h of x, now a product might look like this, f times g of x. This is a closed circle. Be very aware that this is a closed circle. Or I could say h of x is equal to f of x times g of x. All these x's are the same, unchanged. If I'm going to have my quotient, it might be written as f over g of x. So that's a quotient. I don't like writing it like this. I would take it to h of x is equal to f of x over g of x. Now, I just want to come back, so this detail that I was just trying to talk about, it's best explained when you have an example. So I'm just going to come back to this question over here. Oh, sorry. Where it had two V shapes, and you're finding the quotient of the functions. So I just want to come back. I just want to backtrack just a little bit. So this is on your release diploma exam from 2022. Okay, and I'm just going to zoom out. So this is what I was talking about when it's like, okay, well, we know we can't divide by 0. So if g of x was given to us in the form of a polynomial, we'd factor it and we'd see all the NPVs. But what if we don't have the graph? What if we do not have the graph here? Okay, so when I'm looking at the quotient, so if it says y is equal to f of x divided by g of x, these x's are the same. You could technically kind of go through each ordered pair and see what's going to happen. But I can't see much of f. Do you guys see that? Like, they didn't really give me enough f. Like, I get to assume that it goes on forever, but they didn't give me a lot of f, okay? Because it does go to the edges, we can assume that it goes on forever. If I'm going to find my f of x over g of x, I'm going to grab some ordered pairs, and I'm even going to grab a few ordered pairs that extend over here. So I can see that f has, like, if it's got -2 and 4, it's going to have -3 and 5. And then it's going to have -4 and 6. Like, I'm going to keep on going with this graph because I want to make sure that I know exactly what it's going to look like in its final output. -5 and 7. So when I'm trying to figure out which multiple choice option we have, what I need you guys to remember is that when it's an x-intercept and it's in the denominator, you're trying to divide by 0 technically, and we can't divide by 0, so those would turn into vertical asymptotes. Can you guys get your heads wrapped around that? So if I tried to find, like, y is equal to f of negative 4 divided by g of negative 4, f of negative 4 is 6, right? Like that's what this point right here was. Like f of negative 4 is 6, and I can extend that graph. G of negative 4 is 0. I just broke math. Does not exist. Whenever I try to divide by 0, how does it present itself? As a vertical asymptote. Do you guys, so right away, you guys need to, so if you don't have an equation, and you know you have NPVs from factors, if you just get a graph, know that the x-intercepts would be the y values falling on the bottom, and the y value would be 0. So right away when I look at which graph is it going to be, it's not going to be C and it's not going to be D, and I've got that 50-50 chance. So I'm looking for the asymptotes, and then probably my next focal point would be like, you know what, I know that I'm going to have an asymptote at negative 4, and I'm going to have an asymptote at 4. Maybe I just want to look at 0. Let's see what happens at 0. So I'm just going to try to put this right back where it was, because I can see that the y-intercepts are different. And so once you interpret that, okay, I can't divide by 0, those have become vertical asymptotes. And if I want to try to find f of 0 divided by g of 0, f of 0 was 4, g of 0 is 2. I can see that so my y-intercept is 0 and 2. Notice that the x value maintains itself. I've got more than enough information for me to figure out which graph was correct, right? So the detail that I really want you guys to attend to is an x-intercept in the denominator will actually give you a vertical asymptote on the resulting function. Does that make sense? And so my 0 and 2 tells me this had to be the graph. Okay? So I just wanted to kind of just draw your attention to that. And I just want, because I need you to know what I meant when I said, like, hey, an x-intercept in the denominator is actually a vertical asymptote on the quotient, right? So just keep that in mind. Okay, so in all of these x's are the same. So every single ordered pair, I don't know why that looks so awkward, but every single ordered pair will have the same x value. So if it was f of 2 equals 3, and then if it was g of 2 equals 7, then h of 2 would have been 3 over 7, but it was all 2's, right? Composite functions, the x values change, okay? So everything that we've been doing with the same x value, same x value, same x value, we don't add the x values, the x values are going to change now, okay? So with a composite function, you're actually inserting one function inside another. So you're basically taking, so technically, the y value from the internal function becomes the x value of the external function. So what does this mean? We're inserting one function inside another. This is one notation for f of g of x. And I'm sorry, I do not know how to use the circle like feature. If it's a hollow circle, it's not multiplication. G of f of x is basically telling you that the y value from f of x becomes the x value of g of x. This is not g times f of x. Like if I had this, that's g of x times f of x. This is g of f of x. The f of x got inserted inside g. Another way of writing this is g of f of x. This is the notation for composite. You cannot use an open circle for multiplication because composite function requires an open circle. Okay? So when you're thinking about it, so this is one way of writing it, this is the other way of writing it, yeah? So if f of x is 2x squared plus 3, and g of x is 4x cubed plus 1, if I'm trying to find g of f of x, I actually have to insert the f of x function wherever there was an x in the g of x function. So a whole function gets inserted inside another. Okay? So I'm going to show you from the ordered pair perspective. Okay? So when you've been given equations and you've been given the gift of a singular number, I'm going to find g of 1 first. G of 1 is inserted. So another way of writing this would be f of g of 1. I'm going to find g of 1 first. So negative 2 times 1 plus 7 gives me 5. So g of 1 is 5. If I am going to find f of g of 1, what's g of 1? I'm now finding f of 5. The y value from g of x becomes the x value for your f of x. So now f of 5 is going to be 3 times 5 minus 5, which gives me 10. Okay? So basically, we started with an ordered pair that was 1 and 5. That was on g of x. And then on f of x, we had an ordered pair of 5 and 10. This y value turned into this x value, which resulted in a 10. Do you guys see that? And so composite function, the x value doesn't maintain itself anymore because this y value becomes this x value. So it's not 1, 1, 1, 1, 1. This y value, so the x values will change as you move along. Can I get you guys to try this one? Work with g of negative 4 and then insert your g of negative 4 into your function f. And it's really just learning the language of composite functions. Oh, you got it. Okay. Hold on. G of negative 4, you guys got 15. So then f of 15 is 3 times 15 minus 5. Okay, and you got 40. Yeah? Okay. I thought you were getting 4. When you did this, I was like, oh, okay, got it. Okay, so guys, just notice. So on my composite function, so this is what my composite function would look like. We started with a negative 4, and we finished with a 40. Like the ordered pair on the composite function is actually negative 4 and 40. The ordered pair on g of x was negative 4 and 15. The ordered pair on f of x was 15 and 40. But on the composite function, we started with negative 4, and our final output was 40. So on the composite function, it's negative 4 and 40. Can I get you guys to try this one? And please know that on the diploma exam, it's not going to be it's not going to be on top. Like it's not going to be higher up. This is just another way of saying f of g of 1. I like this notation so much better. I'm going to find g of 1 first. G of 1 is 8. Insert the 8 into your f. F of 8 is negative 8. My composite function then, so if I say what is f of g of 1, I get negative 8. My composite function will have the ordered pair 1 and negative 8. I had a student writing the unit test once. I don't know, like maybe she must have spaced during this lesson or something, because on the unit test she sees this hollow circle. She's like, what does that mean? I can't tell you on a test what it means. You guys get that, right? So just make sure that you know that the hollow circle is different than multiplication. It means something different. So that 2, 9, 10 assignment that I've had you guys working on, There's questions on the back page that have composite function questions. Can I get you guys to try this one? And I always love like working with numbers. The numbers, like if you get a number, if you get the gift of a number, work with it. It's so much easier to work with numbers than it is to work with like the full equations. Okay, this is kind of giving me the idea that because 1 gave me an output of -8 and -4 gave me an output of -8, like this might be a polynomial function where it just went up and down, or like if you wanted to, you could actually look at it. For this guy, it's f of g of x. You would actually have to insert this quadratic in for x here and then simplify, and you would see that it's actually a quadratic. Okay, that's how you'd work with the equation, which is what we're about to do now. Okay. So from the graphical perspective, we've seen this graph a few times. If I'm going to find g of f of -1, g of f of -1, make sure you're looking at the right graph, right? Like, so this is my f of x. F of -1 is 4, right? So if f of -1 is 4, this, remember with the other ones, it was always like, oh, x is, if x is -1, we were just looking at all the -1s. That's not the case here, because if f of -1 is 4, now I'm finding g of 4. G of 4 is 1. And so final answer is -1 and 1 on the composite function. Yeah.
Isn't that still the f of x arrow?
Totally was. Yeah. Yeah. I was looking at g of x. Thank you. And in my head, I'm like, oh, just don't get the graphs confused. And I totally got the graphs confused. There we go. And so this is 4. Yeah? Is that better?
Yeah.
Did you fix me, Hannah?
Yeah.
Okay. For B, what was it asking for? G of f of -2. G of f of -2. Guys, what's f of -2? Stein, what's f of -2? Okay. And then what's g of 5? So f of -2 is 5. G of 5, and I'm going to look at the right spot. G of 5 is 6. What that means is on the composite function, when we started with an x value of -2, our final output is 6. Yeah? Okay. Now we have to work with the equation. And this is kind of cool, because a function can land inside itself. So you can take a function and put it inside itself. So we don't have numbers this time. We don't have a graphical representation. If I'm finding f of g of x, g of x is the internal function. This is my g of x. I'm going to replace the expression g of x with x squared plus 6. What that means is this whole thing has to be inserted to the x of f of x. I'm not finding f of x anymore. I'm finding f of x squared plus 6. Do you guys see that? So what used to be an x now must be 2 times. We're inserting the whole function into, so the internal function gets inserted into the external function. and then I distribute and I simplify. So I'm just going to write this as f of g of x because that was my original expression. And I'm going to have 2x squared. Are you guys going to be okay if I do this in my head? 12 minus 9, and I go plus 3 right away? Is that going to bother you guys? Okay. Now, something you should always look at is, are there any restrictions on x? Absolutely not. Quadratic, there's no restrictions. So this would be my composite function equation. For this one, you're finding g of 2x minus 9. So this time, instead of x in your g of x, you have to replace it with this whole binomial of 2x minus 9. And just remember that you're squaring a binomial, right? Yeah? Did you guys get that? Are we good with this? Yeah? Okay. Last one. If f of x is 2x minus 9, and we're asked to find f of x, we actually have to put 2x minus 9 in wherever we had an x before. So where you see an x here, and we've already put the 2x minus 9 into the x spot, so where you see an x, just make sure you replace it with the 2x minus 9, and then we simplify. So my f, and I'm just going to use the other notation so you guys feel comfortable with it. My f of x is 4x. This is minus 18 minus 9, which is minus 27. Are you guys okay that I kind of left ahead and I didn't show that step? I hope you guys see where the minus 27 comes into play. So we can actually put a function inside itself. Okay? So these are all the entry-level questions for composite functions. That's the last example on the page.
How many functions do you put inside this?
Up to 3. You can go like up to 3. That's what they're going to have on the curriculum, is up to 3. One function inside another inside another. So up to 3. Okay. Now, you're saying like you could go f of f of f. Yeah. Well. So if you were going to go f of f of f, I would have figured out f of f, and then on this guy, if my objective was f of f of f of x, on this guy, I'd put the 2x minus 9 in again. And then I would just, so I would do f of f, and then I'd go 4, and then 2x minus 9. I would take it one step at a time. And then I would, like, so I'm inserting another f, so you work your way from the inside out. So yes, you can have f of f, or g of g, or f of g of h. Okay, so up to 3, okay? Now, if you conceptually understand that the internal function had to have a y value, this is not going to be a stretch. Okay, so consider f of x is equal to x squared minus 5, and g of x is equal to the square root of x plus 2. This one is really tricky, okay? Restrictions on the variable x of the internal function maintain itself. Everything that was tricky in this unit was all about domain. This is a story of domain, and this is your higher level this is your higher level idea. Anything on the internal function, restriction, maintains itself. Guys, if I can't get a y value, can that y value become the x value of the external function? Does that make sense? Like if I have, let's say g of x has an ordered pair of -2 and error, okay? And then I'm supposed to put g of x into f of x. Can I insert that error here? No. If it doesn't exist on the internal function, it can't exist on the external function. You know what I mean? Like it can't exist on the composite function, the big piece. Like, so when you look at this g of x, so it says consider y is equal to f of g of x. So y is equal to f of g of x. Okay? My new function, I'm going to insert my g of x into my x here. So if I put the square root of x plus 2 all squared, and then I subtract my 5. If I had put a -3 in here, what would have happened? I would have had the square root of -1 minus 5, and I would have gotten an error. It's not possible. Do you guys see that? So whatever restriction is on the internal function, that restriction maintains, no matter what happens when you're simplifying, that restriction maintains itself. Okay? It's just like stating your NPVs before you simplify. You need to state your restrictions before you simplify. I know that this is a radical function. X plus 2 is greater than or equal to 0. X has to be greater than or equal to -2. At the end, I'm going to have to keep that restriction. So, guys, the square root of x plus 2 all squared, do you guys see that the radical disappears? So the square root of x plus 2 all squared becomes just x plus 2 minus 5, and we have a linear function, x minus 3, but if I don't put comma greater than or equal to -2, I'm wrong. Okay, I'm going to show you that if you put in the composite function before you simplify, you'll see the restriction, okay? So what was it, x square root of x minus 2? Sorry, my calculator takes a little bit of time here. Okay, so I have bracket the square root x minus 2, close the bracket, not yet. Okay.
It's x plus 2.
Okay, just teasing. X plus 2. Okay, and then it's squared. And then what was the last number? -5?
Yeah.
-5. Okay. So this is, I can see the composite function inserted. Because it started at the -2. Okay. If you had put in just your simplified, oh, it's x minus 3, it shows you the full line. Guys, the restriction maintains itself. Okay, so just like you state NPVs before you simplify, we state the restrictions before we simplify. So I'm going to ditch this other line of x minus 3, and I'm going to make sure that I can graph this, but we start the domain at x is greater than or equal to -2. So if I wanted to graph this function, maybe I put -2 in here. So if I have y is equal to -2 minus 3, which gives me -5, so I'm going to put my -5 here. Y is equal to, and it's got to be greater than or equal to, so I'll grab the next one. So -1 minus 3 equals -4. I can see my y-intercept of 0 and -3. Are we okay with that? Maybe you're going to find your x-intercept. Of 3 and 0. But regardless, we've got more than enough information here. I'm going to make sure I plot my -2 and -5 accurately. But you have to show me the graph. So there's my -2 and my -5. And it's a start point. It's not a hollow circle. It's not an asymptote. You're starting here because we could equal the -2. Remember, the restriction is greater than or equal to -2. And then I'm just going to graph my function. So I've got -1 and -4. I've got 0 and -3. I totally lost track of. And then I'm going to make sure my x-intercept is accurately graphed. So this requires a restriction. Just like when you simplify rational, you always take all the NPVs. This requires a restriction. Your domain, let's do an interval notation, is going to be -2 to infinity, or you could say greater than or equal to -2. Your range is going to be -5 to infinity. The internal restriction maintains itself. Even if the simplification gets rid of the radical, the internal restriction maintains itself. So this is what we have. It says the domain of f of g of x is the set of all values of x in the domain of g for which g of x is in the domain of f of x. Okay, just remember that the inner function and the composite function get considered. The external function doesn't really matter, it's just the internal, because remember the y value of the internal function becomes the x value of the external function. You can't put an error in and get a y value, right? Like that doesn't exist. Can I get you guys to try these two? Guys, were there any restrictions on the internal function? Is there anything that says that x can't be something on this internal piece? No. When I simplify and I'm done with my composite, there is going to be a restriction though. So you have to consider the internal function restrictions and the final composite function restrictions. And I just remember that h and k would be my start point, and there's no reflections. So my domain, x such that x is greater than or equal to -7, x is now in the real number system. So the final composite function matters too. But guys, you could type this into your calculator before you simplify and look at it and get your domain and range from that. As soon as I reverse this process and put the square root of x plus 2 in for x and g of x, the internal restriction maintains itself. There was no simplifying, so there'd be no reason for you not to write a domain of x is greater than or equal to -2. There's no reflection across the x-axis. There's no reflection across the y-axis. My start point is -2 and 5, and I know that I'm curving up and to the right because there's no reflections. So I know that my domain is x such that x is greater than or equal to -2. X is now in the real number system. Range, y such that y is greater than or equal to 5. Y is now in the real number system. Yeah? That's the thing people forget. The internal restriction maintains itself no matter what the simplification process looks like. Okay, now this one actually takes a little bit more intuition than you'd probably like. And it takes just a little bit more knowledge and understanding of what it means to be a composite function. So this is actually saying h of x is equal to f of g of x. But guys, we've been given this piece, and we've been given the external piece. So when I look at this, h of x is going to be my x minus 4 is equal to now instead of x, I'm going to replace it with the notation g of x. You guys see that my external function was x squared, and if I'm going to insert g of x into that, it would become g of x all squared, yeah? How would I solve for g of x if g of x is stuck inside a squared symbol? What you have to do, positive or negative, okay? So whenever you apply the square root, it's positive or negative square root. X minus 4 is g of x. So either you would say g of x could be the square root of x minus 4, or g of x could have been negative square root x minus 4. And you wouldn't get full marks if you didn't acknowledge that I could have squared this whole thing and gotten this, or I could have squared this whole thing and gotten this. Do you guys get that? Like, if I take negative square root x minus 4 and I square it, that's like negative 1 squared, and then the radical squared, which would have just given you the x minus 4. Do you guys see that? So that you have to take the positive negative. Whenever you're thinking solving, you have to take the positive negative. Now this one is tricky. Okay? So when you're thinking h of x is equal to f of g of x, there's a whole function that gets inserted into f of x. So, if h of x is this, x squared plus 6x plus 5, and f of x is x squared minus 4, but we've got to insert g of x wherever we see an x. So this is going to become g of x all squared minus 4. Are you guys okay with this so far? Okay. Now if I wanted to solve for my g of x, I would add 4 and add 4. Now I'm going to show you the most common wrong answer. You wouldn't just take the positive negative square root to isolate for g of x this time. Not just the positive. What you guys should recognize is that this is a perfect square trinomial. That if you factor this, it actually gives you x plus 3 all squared. Do you guys see that? So if you took the positive negative square root of this, you're not wrong, but you didn't simplify it all the way because it's something you can actually square root. So when you look at the question on the left-hand side, and we see that it can be x plus 3 all squared, then clearly the internal piece must be equal to each other. G of x must have just been x plus 3. And you don't have to put brackets around it. But then I would go back and I would just double check. I would do a quick check to see if I did get the h of x when I used that composite function. So a really quick check would be, okay, I'm going to find my f of g of x. And so if I put that x plus 3, I square it and I subtract 4, do I get the h of x, right? So you get your x squared plus 6x plus 9, and I got it, right? Like I can double check. But this became a little bit of intuition of, okay, it was something squared on the right. Can I make it look like something squared on the left? Over here, there was nothing I could do with the x minus 4. Like clearly nothing. Okay? So I want you guys to try some practice test questions now. If f of x is equal to 1 over x plus 5, and g of x is equal to 6x minus 1, then what is g of f of negative 2? If you're given a number, work with the number. Work your way from the inside out. Tell me you guys got A. Yeah? What I need you guys to recognize here is that we started with an x value of -2 and the final output was 1. So your composite function has the ordered pair -2 and 1, right? F of x had the ordered pair f of -2 is 1/3. G of x had the ordered pair g of 1/3 equals 1, but the composite starts with the -2 and finishes with the 1. Okay, try this one. Here's your triple composite function. But you just have to work your way from the inside out. There's a number there. So I would just write this as f of g of h of -8. And I would find my h of -8. Put it into those brackets. And then find g of that number. Put it into the brackets. Do you guys remember where your absolute value button is on your calculator? Like, just in case you didn't know, just push math over to number, and that's where you get your absolute value. So when you put in like your -8, what was it? I know you guys know how to do this in your head, but -8 plus 2, right? So -8 plus 2, you know that it's 6, right? So guys, this y value became that x value, and then I'm going to find g of 6. Did you guys recognize that you needed to find g of 6? And then finally, f of 20 would be 20 squared minus 1, which gives you 399. So, wait, and always bring it back to the final expression. If they use this, bring it back to that. Tell me that my initial x value was -8 and my final y was 399. So on the triple composite function, there's the ordered pair -8 and 399. So the initial x value becomes the x value of your initial composite function. But along the way, we had different x values. So this x value, this y value of 6 became the x value of 6 in function g. We had the ordered pair 6 and 20. This y value from g of x became the x value. Like, final answer, bring it back to your triple composite. You try task number 10. Guys, I'm just going to work with 2 at a time. I'm going to find my g of f of x first. So g of, and my f of x was the x minus 1. So I'm going to put my square root of x minus 1 into my g of x. Only the square root of x minus 1 is squared, and then we've got the plus 3. Are we okay with this? Guys, this internal restriction matters. X minus 1 has to be greater than or equal to 0. X has to be greater than, we got to keep that with us the whole way through. This would simplify to become x minus 1 plus 3. And then when you put your like terms together, we end up with x plus 2. But put a little comma behind it. Do not forget the fact that there was a restriction. So when I see my g of f of x, it simplifies to x plus 2. X is greater than or equal to 1. So there's that first piece. And then I've got to take it to, if I'm going to use this and I'm going to find h of g of f of x, this is x plus 2. So what I'm finding is h of x plus 2. H of x plus 2, so when I look at my h, we're going to end up with 2 bracket x plus 2 minus 5 distribution, and I get 2x plus 4 minus 5, and then final detail, 2x minus 1. So this triple composite function, we're labeling it as k of x, but the internal restriction had to stay with us the whole way through. So when it says state the domain, just don't forget, like, no, people do not have to explicitly ask you for it. Your k of x requires it. Like, you have to make sure that the domain becomes part of your statement for k of x. Yeah? Work your way from the inside out. Okay? Okay, now we can have composite functions, and we can have sum and difference all in the same question. And we're going to throw logarithms in there because we love them. Right? So if I look at this and I see f of f plus g of 8, and we have a whole a whole function sum inside another function. Let's first find out what f of 8 plus g of 8, like, let's figure that out first, and whatever we get for that output, that gets inserted into function f in the end. Because remember, like, this is just the internal piece, and we're just working our way from the inside out, but we're going to have to put whatever we get at the end into function f. So f of 8 would be 7 log base 2 8. Okay, guys, thinking logarithms. 2 to what power gives you 8? That's what you're asking yourself. When you see a logarithm, you're asking yourself, 2 to what power will give you 8? 3. So my f of 8 is going to be 7 times 3. My f of 8 is equal to 21. Now I have to find g of 8. G of 8 is the absolute value of 5 minus 6 times 8. Guys, what's 5 minus 6 times 8? It'd be like 5 minus 48, which is negative 43. The absolute value of negative 43 is just going to be 43. Are you guys okay with that? So this, f of 8 plus g of 8, becomes 21 plus 43, which is 64. Now remember, we weren't just looking for the sum. We had to figure out that sum so we could insert it into function f. So now I'm finding f of 64. And we love merging with other units of study that we should feel comfortable with. And I lost the 7 in front. Guys, what's log base 264? Who knows what 2 to what power gives you 64?
6.
Totally 6. Okay, so then if I'm going to find this, I get 7 times 6, which is 42. I'm going to bring it back to the original statement of F bracket F plus G. So we started with an X value of 8, and the final output was 42. So the ordered pair that's on this is 8 and 42. Are we okay? Yeah.
Work-wise, could you just do the long way, like just put all the numbers in the long equation?
In the one equation? Like, so you just wanted to go F, and then you wanted to just put 21 plus 43. If it's written response and you don't justify the 21 and the 43, you won't get credit for it. Okay? If it's multiple choice, you know you can do that. If it's written response, it's worth 2 marks, twice as much as a multiple choice numeric response. Anything you're doing in your head, you need to put it on paper. Okay, so any written response on paper, every detail, every thought process written down. Okay, try this one.
Is there a way to like develop a written response or a target for here?
What do you mean?
Like if I know the answer but I don't know how to show the word for the answer.
You'll get 0. Like they showed us again and again and again. This student had the answer. This student gets 0. Like if there's no marks for answers alone. People guess and check in their calculators all the time, and then they try to like BS work that gets them to that. It's 0. Like, and they showed us they sent out a document. They're like, see this guy had the right answer, 0. See this guy had the right answer, 0. They had no work to justify the answer. They had work shown that was gibberish and didn't make sense in the context of the question. They just randomly showed. So there is no, like, you will get 0, like solid 0. Even in 30-2, you get 0. Okay, so guys, 2 functions are shown below in the form of an ordered pair. Could you guys find g of f of 3? I always like to rewrite it like this, and then I just find my f of 3. What's f of 3? F of 3 is 5, so then I find g of 5. G of 5 is 8, so final answer, g of f of 3 is 8. This would have the composite function 3 and 8. Okay, I'm going to leave, I think that we have, what, 2 pages left? Oh, 1 page left. I'm going to leave that for tomorrow because these are high-level questions. I think at the bottom of this page, I do have another assignment. Yes, I do. So this is the last textbook assignment I'm getting you guys. This is it. When am I checking them? I'm checking them on Monday. So keep that in mind. You want to get all of these done. So page 5. Can I get you guys to pack up and go to the whiteboard on questions? Okay. In addition, you know that your test is next Wednesday. So I put in Google Classroom your study notes. Okay, study notes. Unit 5 study notes. Okay. Unit 5 study notes needs to have some information from Chapter 2, particularly the steps for when you're taking the square root of a function, like ignore everything below the x-axis. Plot the invariant points of y equals 0, y equals 1. Like, you should have the steps written down and an example. Chapter 9, you have to talk about all the critical features, including points of discontinuity, and you need to show how to develop the equation of a rational function using critical features. And then Chapter 10, sum, difference, product, quotient, focus on domain and domains of these, and composite functions. Guys, if you don't have this, there is no bonus mark. You can't just give me, this is enough. If you don't have these features, it's not enough. You don't get the bonus mark. Brody, you get that? Yeah. Okay. So, guys, at the whiteboards, let's try f of x is equal to the square root of x minus 1. G of x is equal to x squared minus 2. I would like you to find h of x if h of x is equal to g of f of x. Can you guys put the little circle in between? Like if you're going to go g of f of x, I know the program I use lifts it up. Don't lift it up. Don't make it a superscript. Just make sure it's g of f of x or g bracket f bracket x, close the bracket, close the bracket. I would like you guys to find h of x.